Well, in this video, I'm going to give you a little bit more help with working with the calculators and entering some formulas. So I have, looks like I got 4 examples of CDF formulas that we're going to practice putting in the calculator. And in this video, we're going to talk a little bit more about the older operating system versus the newer operating system, and this will all be on the TI-84. First of all, if you've got the new operating system, when you go to mode, you can turn it into the old operating system, essentially, by going to Classic View. So I'm going to put it on Classic View, which is essentially going to make it like the older calculators. So I'm going to start by doing these problems as if they were in the older calculator, and then I'm going to show you how to put them in and what it would look like with the newer operating system. So in either case, you're going to start by pressing the Y equals. If you have one of these plots turned on, it'll have a dark background like that. So if you put your cursor on it, hit enter, be sure you turn the plots off. So we don't want those on. If you have any other graphs in here, you need to toggle them off or just delete them. Clear them out so that we don't have any other graphs going. So we just want one graph at a time. Okay, so let's look at this first one here. One thing you have to understand is that a slanted fraction line is not the same thing as a horizontal fraction line. So let me just type it in this way down here. Look at the bottom of the screen. If I type in 1 divided by 2 plus 3, what that means is the same as taking 1/2 and then adding 3 to that, which in decimal form is 3.5. Okay? If I want to have this, a horizontal fraction line, 1 over 2 plus 3, notice that that is a grouping symbol as well as being a division. And so what that means is that I first take this and add the 2 and the 3 together, and then divide 1 by 5. So in decimal form, for example, that's 0.2. So notice there's a difference in the order here. Division comes before addition, but this fraction line, horizontal fraction line, is a grouping symbol. So if you want this here, you can't write it like this if you want to add the 2 and the 3 first. You can write it with a slanted fraction line, but then you also have to insert a set of parentheses like that. And that would be the same thing. So, with that in mind, one of the things that we need to remember is we need to put parentheses around the entire numerator and around the entire denominator. Now, if the numerator is just a single number like this, we can get by without the parentheses. You can still do it. It's optional. Likewise, if we do a power and then a multiplication, powers happen before multiplication. So we need to put that power in parentheses. So in the older operating system, this is how it would look. 1 divided by, put a parentheses for the denominator, 1 plus 2. To get e to a power, that's right here in blue above the ln key. So second here. That caret means to the power, and the power is in parentheses, negative 0.4x, close parentheses. That closes the power. 1 more closes the denominator. So notice we have a total of 2 open parentheses and 2 closed parentheses. Now the next thing we need to do is we need to worry about what a graph is going to look like. We need to worry about the window. Now since this is a CDF, we basically need our y min to go from 0 to a y max of 1. Now I typically will make this go a little smaller. Negative 0.2 or even negative 0.3 works pretty well. And then go up to like 1.1. It's a bit of trial and error on the x's. So if we graph that, on a CDF, we'd expect it to see it start at 0, be continuous, continue up, and go to 1 here. And it looks like we're pretty much got a pretty good window, although it's little, maybe we haven't quite leveled out here all the way here. So we might want to go a little further to the right. Let's try 30. If we're going to go that wide, we might want to put the marks at 5 here. So 5, 10, 15, 20 on the marks on the x-axis. Okay, that's pretty good. We can definitely see it leveling out to 1, leveling out to 0 on the other end, and increasing in between. There we go. That's a good window. If we were to choose a much bigger window, like negative let's say negative 200 to 200, then this is probably a little bit too big, because you'll look and you'll see a lot of the graph is just on the axis here and a lot is up here at y equals 1. The interesting part here is kind of scrunched up too close to the axis, and we've got a lot of screen with the boring part happening. On the other hand, it's even worse if we go too small, like we only went from negative 5 to 5 for the x's. Then we see that there's a gap here. We didn't make it all the way down to 0, and especially a gap on the right where it's not making it up to 1. So there we didn't go wide enough. So I think negative 20 to 30 is what we came up with before. That seemed to be sort of just right. So you kind of just play around with this a little bit, guess and check until you get a good looking window. Okay, continuing in the old operating system, I'm going to put all these in, then I'm going to go back and show you what it looks like in the new operating system. Okay, so on Y2, on the Y1 here, 1 minus 2, and it does imply multiplication, so you can just go e to the power, negative x divided by 5, close parentheses. Now, by the way, notice the difference between a subtraction and a negative. A negative is something you put on a single number, so this says take x divided by 5 and then multiply by negative 1, or take the opposite sign of it. Okay? A subtraction is something you put between two numbers, and there are two different keys and two different things on the calculator. Subtraction is one of these gray keys on the right, one of our basic operations. The negative is one of the white keys down here near the bottom, or at the bottom, which looks like this. And they look a little different on the screen. The negative is a little higher and shorter, and the subtraction is a little bit bigger and longer and right in the middle. So if we graph that, now this particular one, if I just hit graph, we have some negatives here and something's out of whack here. So in fact, this is not a good PDF. So I could say this probably works from some value here. Actually, I want to change that. I want to change that where it doesn't have the 2. So let's go back and change that here. Now, notice we have some negatives over here. That doesn't make sense. Well, in this one, the formula is only defined for x as being greater than or equal to 0 by this formula. It's 0 otherwise. So I want to ignore this part of the graph over there. So that tells me that I need to set my x window starting at 0. And then I want to go to the right. Oh, let's go out a little further. Let's go out 50. Now what we should see is it start at 0 and then go up to 1 and level out. It might actually have an asymptote, or it might actually be 1 from some point over this one as an asymptote. Again, notice the negative in the power. Notice that we put the whole power in parentheses. The caret just means that's e to that power, which you get by second ln, and that is subtraction in the middle. Okay. The next one, I put in the formula. I'm going to put the 1/3 in parentheses. Open another parentheses. By the way, to get x, the easiest button to hit is right here next to the alpha key. It says xt theta n. When you're in regular graphing mode, that's just the x. You can also get it by doing alpha, wherever x is, alpha, the store button will give you x. But it's easier just to hit this button right here to get x. And then this is subtract 9, close parentheses. Now I can either do power 2 like that, or since it's a square, there's a shortcut for that particular one because it's used so much, which is just square like that. Okay, so that will give us the basic formula. Now, there is a way to put this in as a piecewise defined function, and I do go over it very briefly in one of the videos, but in reality, you don't have to use that. In fact, it's just more trouble than it's worth. We just need to know that this formula only applies from 9 to 12. So when I set my window, that tells me to set my window from 9 to 12 for x's. If I'm going to do that, maybe I'll mark the x-axis every 1. Here I'm using negative 0.3 to 1.1. That's a good window to use all the time, or negative 0.2 to 1.1 works pretty well. And this should go from 0 up to 1. No, it doesn't. That's not a good formula. So that tells me that's not a legitimate CDF. I need to fix it. And the way to fix it is I need to fix this to be a 9 here. Okay, that's one of the ways to fix it. So let me change that. Okay, now let's see what we have. Ah, there's a legitimate CDF. It starts at 0 and goes up to 1, and that's when we went from 9 to 12. So that does work out right. Check it out. When I plug in 12 minus 9 is 3. 3 squared is 9 times 1/9 is 1. Plug in 9. 9 minus 9 is 0. Square root of 0 times 1/9 is 0. So it does start at 0, go to 1, and it's increasing the whole way. Now after this, the formula no longer applies. From there on out, it's just a horizontal line to the right at 1, and to the left of this, it's a horizontal line at y equals 0 out to the left. But you really don't have to graph this part here. Okay. Let's see if I did this right. Yeah. Okay, let's do one more. A square root you can find by going here, square root of x. And this calculator, you know what? Let me change the formula a little bit just to make it a little bit more fun. So let's go to 82 and then start at 1. I'm shifting this thing a little bit just to make the formula a little bit more interesting to put in. Okay, so let's make that the formula. Notice the square root, when you write a square root like this that extends on out, it's going to be a grouping symbol as well. But the square root here in the older operating system opens the parentheses for you, but you have to close the parentheses when you get to the end of the square root. And I can divide that by 9. So if I did this right, let's check it out. 82 minus 1 is 81. Square root of 81 is 9. Divided by 9 is 1. 1 minus 1 is 0. Square root of that is 0. Divided by 9 is still 0. So this does go from 0 to 1 as we go from 1 to 82. So our window then goes from 1 to 82. Let's mark it out and say 10s there. And graph that. And that's the important part. Now once it gets right here to the end of the screen, from there on across it's just 1, and to the left of this it's just 0. But the important part is this part in the middle, which is what we graphed. So that's how we put things in the older operating system. Now let me show you some things that look a little different in the newer operating system. Okay, so let's go back to mode, and I'm going to go to make sure the Mathprint is turned on, and show you how some things look a little bit differently in the Mathprint. So let's put in these same formulas that way. Now we can actually, with the Mathprint, can actually get these things to look basically just like they do on the screen. So if we want a horizontal fraction line, you can get that. The easiest way to get it is alpha y equals, which is F1, and choose the very first one, numerator over denominator. Hit enter, and it gives us a fraction. We put 1 in the top, down arrow to get to the bottom, 1 plus 2, then we put in our e to the x, okay, and then this is a, now notice it puts you up in the power when you did that. Instead of showing the little caret thing, it actually puts you in a power, in a superscript for power. And now since you're in the power, it's already grouped, so you can not necessarily have to put parentheses around the power, although you could, and we could put it in like that. It is also would be acceptable to put parentheses around the denominator and parentheses around the power, but they're not really necessary because of the horizontal line and the exponent, the superscript on the exponent, being grouping symbols themselves. So if we go back to this, I don't remember. Let's see. It seems like it was negative 20 to 30 is what we ended up using last time. Yeah, there it goes. Same graph as we had before. But if you notice, it actually looks pretty much, well, not as pretty as the math type over here, but basically looks the same as you would write it by hand or with the typeset mathematics. Okay, similarly, we can do 1 minus, again, e to the power already puts us up in the power, and I think, let's see if this will work. I'm not sure if this is going to work here. Let's see if I can now go to here and put a fraction. Yep, it'll put a fraction right there, and we can do x over 5. Out in front of that, however, this left arrow, I want a negative out front. So that is basically just like it looks here. And this is going to be from 0 to the right, so I need to set x min to be 0. Let's just try 30 to the right and see what happens. Yeah, that's going to be fine. It's pretty much leveled out, going from 0 to 1. And the last one with the Mathprint, again, I can start with a fraction, which is alpha f1. And I can say square root, which is here. Now notice the square root here, I don't need the parentheses necessarily because the x minus 1 stays under the square root. If I do a right arrow, that gets me out of the square root, down arrow down to the denominator, and 9 here. So now it looks like it does when you write it out the normal math way. And let's see, this is going to start at, well, really from 1 and then go to 82 and mark it off with tens is fine. So that's what that should be. So it should start at 0 right here at 1, and at 82 we're up at 1. Okay, so let me show you just a couple more differences in the this here. For example, if I have something like this and I do, let's see if I do a trace, and if I put in 5 here, it gave me a y value in a fraction form. So that's kind of interesting. If you use the fraction thing, sometimes it will give you fractions. Now that's okay. If I can also do here from this. Remember, if I want the y1 on the home screen, one way you could do it with the older operating system is go variables, right arrow to y variables, choose number 1 function, and then y1, and say of 5, let's say. Because of the pretty print stuff, it comes up as a fraction. Come back to that in a second. As you see this up here, F4, which is alpha trace, this gives us a shortcut to y1, y2, so forth. So just hit enter. That's going to be the shortest way to get to y1 on the calculator. Now, if this is in fraction, you want to change to decimal, there's a couple ways you can do that. One is under math, and you can say change to decimal. If you have it in decimal, you can go math, change to fraction. And so that will change it back and forth. I think you can get the same thing under alpha F1, and fraction to decimal is number 4. And this is back and forth. So if I just hit it, repeatedly, it's going to just go back and forth between fraction and decimal. So there are a couple little differences there, and I'll point out other differences in the operating systems and the way things look as we go along in some of the other videos. But I thought it might be useful to help just help see these, how they look in your graph a little bit in both the pretty print from the new operating system and also in the old classic operating system. If you have a TI-83, everything's like the old version of what I just showed you, and you cannot upgrade it. If you have a TI-84, however, they're all upgradable, and you can upgrade them to the new operating system for free from Texas Instruments website. Or if you're in my class and you can make it to my office during office hours, I can use my calculator to help upgrade yours to the latest operating system, and you'll have the newer version here. What's nice about the new version is that you can get things to look pretty much the same way that they do when you graph them, when you write them out by hand or with a good typeset mathematics.